Okay, so rationalizing denominators is the first part of the, well, part 2 radicals. Okay, when we're talking about rationalizing denominators, it just means writing a radical expression without a radical in the denominator. Okay, so if you have a radical in the denominator, this is not proper mathematics. Proper mathematics says that we aren't supposed to have radicals down in the denominator. So we want to be able to get rid of those. So in order to get rid of them, what you have to do is create your own perfect squares or cubes or perfect radicals. For instance here, okay, I have the square root of 2, which is some ugly little fraction, but this is a square root, so if I have two 2's, I would be able to take them out of the radical. So if I multiply by another square root of 2, well, now I've got two 2's underneath the radical. And whatever I do to the bottom, as long as I do it to the top, then it keeps the same value, because technically I just multiplied by 1. Because the square root of 2 divided by the square root of 2 is just 1. So I really multiplied everything by 1, only I made my 1 look a little bit different. So I haven't changed the value, I'm just changing the way things look. So on top here, I get the square root of 3 times 2, and on bottom here, I would get the square root of 2 times 2. Well, when you're talking about radicals, well, that would be my group of 2, so it would come out as a 2. Okay, or if you want to multiply it together, you would get square root of 4, and the square root of 4 again is just 2. And then on top here, I've got the square root of 6. I know it doesn't break down any further, because that's a 3 and a 2. Okay, so it's not going to break down any further. Let's see if I can zoom in a little bit here. Totally wrong button. Okay, not, no, that's the right button. Okay, so, 6 is, it breaks into a 3 and 2, so I don't have any groups of 2, so it's just the square root of 6 over 2. But now I've rationalized the denominator. I no longer have a radical in the bottom of my fraction, and that's what it means to rationalize. So same sort of thing here on 2 over the square root of 5. If I want to rationalize, well, I need another square root of 5. Okay, and as long as I do it to the top and bottom, I'm going to multiply that in there. 2 times square root of 5 is just 2 square root of 5. Remember from the last unit, you multiply outside pieces together and inside pieces together. Okay, I can't do anything with this because this is in the radical and this is out. On bottom here, I would get 5 times 5, which is square root of 25. Okay, or on this one, I didn't multiply it because you don't really need to multiply it, because here I've got a group of 5's. Okay, if I were to undo this, 25 would become 5 and 5 again. So that's my group of 2. So my final answer here is 2 square root of 5 over 5. Okay, that's rationalizing. We're just trying to make perfect squares or whatever the root is, and we'll look at some with bigger roots here in just a second. So let's do one more of these. Okay, it is important, and the best advice that I can give you is make sure you check to see if you can simplify anything first. Okay, for instance here, the square root of 16. Well, the square root of 16 is just 4. So that means 2 times 4. On bottom here, okay, if you look at it, well, the square root of 9, if you remember, we can take out just pieces. Okay, so the 3 can come out. Now the x, there's only one x, and I named groups of 2, so the x has to stay. So I still have a radical on bottom that I need to get rid of. So if I want to get rid of the square root of x, I'm going to multiply by the square root of x, square root of x. Okay, and that way I've got 2 x's on top. 2 times 4 is 8, square root of x. On bottom, 3 square root of x squared, because x times x is squared. Okay, so now I've got my group of 2, which I can take out. So 8 square root of x over 3x. Okay, you can't do any simplifying here because this is under the radical and this x is not under the radical, so your answer there is just 8 square root of x over 3x. Okay, so now let's take a look at a fraction. Okay, remember, anytime I have a fraction underneath a single radical, I am always able to split them apart. Cubed root of 1, cubed root of 2. If you don't remember this stuff, go back and look at your notes from last unit, okay, because that's all last unit skills. The cubed root of 1 is just 1 because I can multiply 1 by itself 100 times and it's still going to be the same thing. Okay, on bottom I've got the cubed root of 2. Now here you have to be careful. So here, when it was the square root of 2, I just multiplied by another square root of 2 because I needed 2 2's to come out of the radical. But now I'm looking at a cubed root, so I need 3 2's. So here, when I go to multiply, it's not enough to just multiply by 1 2. I need to multiply by 2 2's, so that now I've got a total of 3. Okay, 1, 2, 3. I've got a total of 3. Okay, whatever I do to the bottom, I also do to the top. Okay, so what I get there is on top I've got the cubed root of 4. That's just multiplying that 2 times 2 together. Okay, so I get the cubed root of 4. Okay, which doesn't break down because that's only 2 2's and I need groups of 3. And on bottom I would get the cubed root of, when I multiply that, 2 times 2 is 4 times 2 is 8. But again, my whole purpose was to make a perfect group there. Okay, so when you take a look at the perfect group, it would be a group of 3 2's. So I would get the cubed root of 4 divided by 2. Okay, if you need to, you can do the break. The 8 breaks into 4 and 2 and 2 and 2. That's my group of 3. Okay, so I get 3 2's, the 2 comes out. So I get cubed root of 4 divided by 2. And that is rationalized. Okay, same sort of thing with the next one. I've got a fraction. I can't simplify it, so I'm going to split it apart. Okay, so I get the cubed root of 27 divided by the cubed root of 4x. Okay, on top, the cubed root of 27 is just 3. And we don't have a cubed root of 4x, so we're going to leave it alone. Okay, nothing simplifies, nothing comes out. Okay, so when I'm going to figure out what I need to multiply in to make a perfect cube, well, first things first is I want to take this and break it down. Because if you look at the 4, that breaks into 2 and 2. So I've already got 2 2's, but I need groups of 3 to come out. So when I multiply, sorry, not equals, when I multiply, okay, I'm going to multiply by the cubed root. Okay, yes, the root does have to match. Okay, so that way I'm allowed to multiply underneath together. If the roots aren't the same, then I can't multiply them. So cubed root, so I've got 1 2 2's, so I need a third 2. Okay, because 2 times 2 times 2 would be 8, and that's a perfect cube. Okay, here I've got 1x. Okay, well, to come out of the radical, I need 3 of them, and that's what I'm trying to do. I'm trying to get these things out. So if I already have 1 and I need 3, that means I need 2 more, so I get x squared. Okay, multiply top and bottom, same thing, cubed root 2x squared. Okay, so on top there, I just get the 3 cubed root 2x squared over, okay, and on bottom, let me block this off a little bit. Okay, when you look on bottom here, okay, the cubed root of 4x times the cubed root of 2x squared would be the cubed root. 4 times 2 is 8. X times x squared is x cubed. Okay, if you want to skip this step, I'm okay with that on your homework. I know I tell you you have to show work, but if you show the multiplication and then in the bottom you just skip to the 2x cubed, or 2x, because that's what you know you were trying to make as a perfect cube, that is okay with me. So you can skip this particular step where you multiply it all together, because it's just going to come back out in a second anyway. So top part, 3 cubed root 2x squared, all divided by, okay, the cubed root of 8 is 2, and the cubed root of x cubed is x. And that's what we were trying to do. We tried to make a perfect group of 2's and a perfect group of x's, okay? That was the whole goal there. So, okay, again, when I told you my best advice to you is to see what can simplify first. So up here, I did the square root of 16, and that was 4, and square root of 9 is 3, and all that good stuff. Make sure you try to simplify first, okay? Because if you look at this next one, the top part here is just the 4th root of x. Well, the bottom part, if you break it down, breaks into 9 and 9, 3 and 3, 3 and 3. So that would give me 4 3's. So the 3 can come out. Okay, the 4th root of y to the 4th, well, I've got 4 y's, so I can take a group of y's out. So I get 3y in the bottom. The whole point is to rationalize, so it doesn't say that I have to multiply things in. I just want to get rid of the radical on bottom. Okay, so if simplifying does that for me, then simplifying does it. I don't have to continue going and multiplying things in when I don't need to. If the radical's gone, the radical's gone. That's all we're trying to do. Okay, so now let's take a look at the next ones. Those are the your turns. I would hit the pause button, see if you can do it. Okay, come back, see if your answer matches up with mine. Okay, so for A, two different ways you could have done it. Okay, one is I told you simplify when you can. Okay, so square root of 6, square root of 3, I can put those under the same exact radical. And when I reduce, I would get 6 divided by 3 is just 2. Okay, that's the easy way to do it. Okay, but let's say you didn't see that. So this was option 1. Okay, sometimes we don't always see the easiest option, and that's okay. There's other options. So let's do option 2 now. Okay, so we had the square root of 6 divided by the square root of 3. By the square root of 3. Okay, so square root of 6 divided by the square root of 3. So a lot of you guys, if you did hit pause and try it, would have multiplied by the square root of 3, top and bottom. And I would have gotten the square root of 18 divided by 3, or the square root of 9, which gives me the square root of 18 divided by 3. Okay, but you have to be careful here. 18 is not simplified. So 18 needs to break into 9 and 2. Okay, 9 and 2. And 9 breaks into 3 and 3. Okay, so the top part reduces to 3 square root of 2 over 3. Well, those 3's are allowed to cancel. Okay, this is all multiplication. There's not an addition or subtraction sign anywhere, which means I can reduce those. So final answer there is just the square root of 2. Okay, both give me the exact same answer. One is just a little faster than the other one. Okay, so same sort of thing with B. Okay, if you did B, the square root of 16 is just 4. So I'm going to do that first. Okay, square root of 2x squared. Well, the square root of x squared is just x. And that 2 is left inside. So the only thing I really had to do was multiply by the square root of 2. Okay, so on top I would have gotten 12 square root of 2. On bottom, I would have gotten x square root of 4. Well, the square root of 4 is just 2. So I've got 2x on bottom. Okay, again, those reduce. 12 over 2 reduces to 6 over 1. So I get 6 square root 2 left on top and an x left on bottom. Last one here. Nothing I can do to simplify those, so I'm going to split them. Cubed root of 2, cubed root of 3x squared. Okay, so when I multiply here, I've got 1, 3. I need 3 of them to come out, so I'm going to do 2 more 3's. 3 times 3 would make 9. So that's 2 3's, right, because I just multiplied them together. 3 times 3 is 9. That's where that comes from. I've got x squared, so I need another x. What I do to the bottom, I do to the top. Okay, again, this is a 9. It's 2 3's, but I multiplied them. I went ahead and multiplied them together. 3 times 3 is 9. Okay, so then on top, I've got cubed root of 2 times the cubed root of 9x, which makes the cubed root of 18x. And on bottom, I get the cubed root of 9 times 3 is 27. X squared times x is x cubed. Okay, so I get the cubed root of 18x over, well, 27 is a perfect cube. Okay, that's why I chose to do 9. So I've got 3 3's. Okay, 3 times 3 times 3 is 27. So I get 3x on bottom. Can't reduce here because this is under the radical. This is not under the radical, so that is just my final answer there. Okay, so that's the end of the your turn. So now the next part is called conjugates. Okay, so when you're talking about conjugates, which we kind of already have in this class, although we didn't call them by that name. Okay, the conjugate of a plus b is a minus b. Okay, so if I have an a plus b, then a minus b is its conjugate. If I had an a minus b, then a plus b is its conjugate. Okay, so anytime I see a plus or minus in the denominator, if I look up here, every one of these just had a single term in the denominator. Okay, square root of 5, square root of 9x, that's all one term. It's all multiplied together. No plus signs anywhere. Okay, if you look at every single one of those, there's not a single plus sign. So now we're going to toss those in. So now I've got a plus sign in the bottom. So I've got a binomial, 3 root 2 plus 4. Okay, so if I want to deal with these, I can't just multiply by the square root of 2, because if I multiply by the square root of 2, well, this one will go away, but then I have one here. Okay, because you would have to distribute. So instead, okay, so when you see, hold on, my screen froze and I can't see what I'm doing up there. So when you see adding or subtracting in the denominator, then you're going to multiply by the conjugate. Okay, that's when we use the conjugate. Oh, sorry, I'm writing and you can't even see it. When you see adding or subtracting in the denominator, so down here in the bottom, okay, that's when we know to multiply by the conjugate. That's what I wrote up there. Okay, that's when you know to multiply by the conjugate. So here we go. Okay, so 3 root 2 plus 4. Okay, I'm going to multiply that by its conjugate because I've got a plus sign, so that tells me I have to use the conjugate in order to rationalize. We're still rationalizing the denominator. My goal is to get rid of this square root of 2 right here. Okay, so to do that, I'm going to multiply by 3 square root of 2 minus 4. You just change that sign in the middle. Okay, and whatever I do to the bottom, I still do to the top. That is always true. When I'm working with fractions, whatever I do to the bottom, I'm going to do to the top of the fraction. That way I don't change the value, because here I'm still multiplying by 1, because I could cancel both of those out and it would go back to the same thing. Okay, so I'm going to multiply that by that. So on top, that means I have to distribute. Okay, so 2 times 3 root 2, if you remember from last unit, you multiply the stuff outside together and the stuff inside. I only have a radical 2 is the only thing I have inside. And then 2 times negative 4 is negative 8. Okay, on the bottom, we're going to have to FOIL, because I'm multiplying this whole thing by this whole thing. So we get 3 root 2 times 3 root 2, which is 9 square root of 4. 3 square root of 2 times negative 4 is negative 12 square root of 2. 4 times 3 root 2 is positive 12 square root of 2. And positive 4 times negative 4 is negative 16. Okay, well, if you notice that when I multiply by the conjugate, this we have already done because they're opposite signs, but the numbers are the same. Okay, my A's are the same, my B's are the same, but the signs are opposite. Those middle two terms are just going to cancel. Negative 12 root 2, positive 12 root 2. Those go away. Okay, and I end up with just the outside term squared. So on top, I get 6 square root of 2 minus 8. I can't put those together because they're not like radicals. This has a square root of 2 and this doesn't. And on bottom, 9 times the square root of 4. Well, the square root of 4 is 2. So 9 times 2 is 18. Minus the 16 that's left over here. Okay, again, the 18 comes from the square root of 4 is 2, and 2 times 9 is 18. So 18 minus 16, and now I get 6 square root of 2 minus 8, all divided by 2. Now, when you are looking at something like this, okay, it's a fraction, which means we have to consider reduction. Okay, the only way I am allowed to reduce is if every term in the numerator can be reduced by the denominator. Because you have to imagine that I can split this to say 6 square root of 2 divided by 2 minus 8 divided by 2. Okay, both of these terms are being divided by 2. So I cannot just reduce half of it. That doesn't work. But here, 6 is divisible by 2 and 8 is divisible by 2. The radical doesn't matter. Okay, because when you talk about the radical, it can only reduce with things inside of the radical. So I can reduce it. 6 root 2, so the numbers here, so 6 over 2 reduces to 3 square root of 2, and 8 over 2 reduces to 4. So my final answer here is 3 square root of 2 minus 4. Let me write that in a different spot. 3 square root of 2 minus 4. 3 square root of 2 minus 4. Okay? So let me say that one more time, because it's super important. It throws people off. The only way you are allowed to reduce the fraction is if every term in the numerator is divisible by the denominator. Okay, so 6 divides by 2 and 8 divides by 2. Okay, if this was a 7, this wouldn't work because 7 is not divisible by 2. If this were 3, Wouldn't work. 3 is not divisible by 2. Okay, so both of them have to be divisible by 2. And you'll get to kind of see that here. So I got a minus sign in my denominator. That tells me I'm multiplying by the conjugate. The conjugate, you just switch the sign here. So square root of 5 plus the square root of 3 is what I'm going to multiply by. Square root of 5 plus the square root of 3, top and bottom, always top and bottom. Okay, so I'm going to have to FOIL twice here. So on top, square root of 6 times square root of 5 is the square root of 30. Square root of 6 times square root of 3 is the square root of 18. 2 times square root of 5 is just 2 square root of 5. And 2 times square root of 3 is just 2 square root of 3. Okay, that's the top. We'll reduce here in a second. Okay, and then on the bottom, square root of 5 times square root of 5 is square root of 25. Now, every time I multiply by the conjugate, those middle terms will cancel. Okay, if you remember, we did a plus b times a minus b is equal to a squared minus b squared. I am okay if you use that property as long as you know when you're supposed to use it. This only works if the outside numbers are exactly the same, but the inside numbers are opposite signs. If they're both negative, it doesn't work. If they're both positive, it doesn't work. They have to be opposites. Okay, so I'm going to do that. So I'm just going to do outside terms, because my two inside terms are going to cancel. I would get positive square root of 15, negative square root of 15. So my inside terms are gone. And then negative square root of 3 times square root of 3 is negative square root of 9. Okay, so now let's reduce everything. 30 would break into 3 and 10. That doesn't reduce at all. So square root of 30. 18 breaks into 9 and 2, which breaks into 3 and 3. I do have a group there, so I get plus 3 square root 2. Okay, this doesn't even break down at all, nor does the last one. Okay, so we get this all over. Square root of 25 is 5, square root of 9 is 3, 5 minus 3 is 2. Okay, square root of 25 is 5, square root of 9 is 3, 5 minus 3 gives me 2 on the bottom. Okay, so here again is what I was talking about before. Okay, 2 does go into 2 here and here, but this is a 3. 2 doesn't go into 3. 2 also doesn't go into 1. So since every single term is not divisible by 2, I can't reduce it at all, so I have to just leave it alone. Okay, so that would be my final answer. Alright, I got one more that I'll do, then you have a your turn. I'll go ahead and throw up the answer for the your turn, but that'll be on you to figure it out. So, 3 square root of x plus the square root of m. Multiply 3 square root of x minus the square root of m. Top and bottom, 3 square root of x minus the square root of m. Okay, it's just the same thing every time, just change the sign. So on top, it's going to distribute. Okay, we're going to distribute. So 2 root m times 3 root x gives me 6 square root of mx. 2 square root of m times negative square root of m makes negative 2 square root of m squared. Go on to the bottom. 3 square root of x times 3 square root of x makes 9 square root of x squared. Middle terms will cancel, so I'm just going to skip to the last term. Square root of m times square root of m makes negative square root of m squared. Okay, negative square root of m squared. So then we reduce. Okay, I only have one m and one x in that first piece, so I can't simplify it. Here I've got the square root of m squared, which is just m, because that's my group of 2. I can take it out. Okay, square root of x squared is just x, and the square root of m squared is just m. Can't reduce anything, okay, because this has got a minus, so these things are bound here. Minus signs kind of bind them. So with that minus sign, it means I'd have to have another 9x minus m in order to reduce, and I don't. So I can't cancel anything. That's just how it is. Okay, there was one last your turn on there. Hit the pause button, see if you can do it. Come back, see if you get the right answer. I'm going to go ahead. Square root of 3 plus square root of 2. Square root of 3 plus the square root of 2. On top, I get 3 square root of 3 plus 3 square root of 2 because I distribute. On bottom, I get the square root of 9 minus the square root of 4, just multiplying outsides because the middle terms cancel. It's the only reason why that's allowed. Okay, on top, those are not like terms. Okay, they're not like radicals. This is the square root of 3, this is the square root of 2, which means they're not like radicals, so I can't put them together. So it's just going to stay like that. Square root of 9 is 3, square root of 4 is 2, 3 minus 2 is just 1. Okay, we don't ever leave 1 on the bottom, we just get rid of it. 3 square root of 3 plus 3 square root of 2. And that is how you rationalize a denominator. Good luck with the first set of homework.